Okay, remember last time I said that I'd see you in this video, but I did leave you with a choice. I said that I'd only see you in this video if you decided to watch the video, and that's what the video is about. That's what this video is all about. It's about options and decisions. As I said last time, conditionally you can come to this video. If you want to watch this video, you're only going to want to watch it if, and only if, you enjoyed the last one. I'm assuming that's why you'd watch these videos, but anyway. So let's start off pretty basic. You're waiting in a park full of people. People are all around you. Some people might brush your arm, kids running around you. That kind of park, right? A play park. And you're waiting for your friends. You're waiting in the park, and you're waiting for them to turn up. And when they turn up, you're going to want to say, "Hey guys, that's what you're going to do. You're going to say, "Hello, nice to see you here. Been so long. Great to get back together with you." Anyway, whatever you'll do with your friends, you're going to do that. But you're only really going to want to do that if your friends turn up. Because let's assume they don't turn up, and then you start saying, "Hey guys, hey friends, how have you been? It's great seeing you here." Then the chances are that everyone's pretty much going to stop what they're doing and they're going to stare at you for a while. And by this point, you don't look very normal to anyone else. You look a bit strange just talking to nobody, and you should probably just leave before they start laughing at you. You know, go and have a cry in private. Anyway, if your friends do happen to turn up, thank goodness for that, and then you start to greet them, you'll make much less of a fool out of yourself. You're going to look a bit more normal, saying, "Hey guys, what's up?" if you talk to your friends and they actually turn up. So this kind of makes the action of greeting your friends optional. It depends on whether they do or don't turn up. If they do turn up, then you'll greet them. If they don't, then they won't. So you have to make a decision based on the condition. There's a condition that your friends come to the park. And we could write it this way. If your friends turn up, greet them. That's if your friends turn up, greet them. Else, if they don't turn up, just don't greet them. Just don't do it. Go straight home before you start crying and get everyone staring at you, because that's going to be really embarrassing, and I'm pretty sure you're not going to like that. Now, a computer can also make decisions just like this one. So a computer can think. No matter what people tell you about artificial intelligence, a computer can make decisions. Okay, a computer can think. It's just not exactly in the same way to the way that humans think. So a computer might decide that it's going to do something if the user has inputted a number, and to do that, then it's going to need to know whether or not the user has flicked a switch to send a number into a computer, or perhaps he's typed a few buttons on his keyboard. That would be a user input. Now, if the user has inputted, then the computer will do work. It will do whatever it needs to do. However, if the user hasn't entered an input, then it won't bother. It won't bother doing anything, because if there's no input and it decides to do what it was going to do with the inputs, and there's no input, then it's doing nothing with nothing, which is pointless, and it's wasting electricity, and it's just a waste of time, to be honest. I mean, if somebody told me, "Hey, I've got a job for you to do," and it was really difficult, I wouldn't bother doing the job unless he'd given me some instructions, or unless he'd given me what I needed to do the job, because it's pointless and it's a waste of time. So if the user hasn't entered an input, then it won't bother. It will make a decision and say, "Hey, I'm not doing this. You can have your whatever you want to do. You can have it back. I'm not taking this anymore." Yeah, this is the point where computers start to get attitude. You know, they start to say, "Hold on a second. Who said you're in charge of me?" This is kind of cheesy. Right, the point is, a computer's only really going to do something if the user puts something into it. That's my phone. Sorry about that. I'll have to pick that up, and I'll continue next PowerPoint slide. So this form of decision making made by a computer is called conditional branching. The easiest way to incorporate a conditional branch into a computer is to put it into the program counter, that the go-to system that I explained last time. So I'm going to explain how you put conditional branching into a go-to system. It involves a little bit of expansion, but I'm going to show you how this is done in Minecraft. Yeah, and we're going to have a conditional go-to system, which is going to be really exciting, and we're going to have a thinking computer, like a real person, which is kind of scary, considering how in the future there have been a few predictions about artificial intelligence taking over the world. Maybe this isn't the best idea to teach you about this. About to hit record. And yeah, I'm recording. I see. I've got to make sure that I hit record on Minecraft every single time now. Not fun. I tell you, the time I forgot that no, wasn't fun. It wasn't very professional at all. But yes, it started recording, and we are back again at my computer. I know it's massive. It's unreasonably massive. You're probably not liking the look of it. By the way, I don't think I've shown you my Minecraft skin. I designed this myself, by the way. I'm quite happy with it. You see, you've got like a chessboard thing. Anyway, I'm not here to talk about Minecraft. Well, sort of, but not my Minecraft skin for sure. I'm here to tell you about go-to systems and conditional go-to systems. So, if you can see here, we've got ignore the white ones. The white ones would just be the wire. But we have these blue things here. Sorry, I'm really lagging right now. Let's do something about that. That ought to help. And it doesn't very much. Anyways, we've got these blue bits of wool here, and we have these grey bits of wool. And the grey bits of wool is what line of code the computer will go to unconditionally. So unless a condition is met. So basically, this is the go-to line. Okay, if you want to go to a specific line of code, you put your program here. You put them on the gray lines. You don't use the blue, just use the gray. However, if you want to make a program which depends on something, for example, if a program depends on this wire being on, okay, you see this wire here that comes along over all these pistons. If you have a program that depends on that wire being on, then what you'll do is, if the wire is on, I'll go to this line of code, and if it isn't on, I'll go to this line of code. So the grey is the unconditional, and as you can see, I don't know if you know how Minecraft works, but basically, the instruction will just go straight through into the go-to system, even if the condition isn't met. However, if the condition is met, it will branch, and you'll use this thing here. And let me show you how that works quickly. This is going to be difficult. Right, so let's put a wire here, and let's power the whole beam. And now the pistons have all gone in reverse. So it will accept this line of code, which runs into this block and will come out the other side. So now it will accept, like I said, this line of code, which is great and all. But we only really have one condition, which is if the wire is on. If we want, say, actually no, that's for the next video, mathematical calculations. But anyway, if the wire is off, it will use the grey command. If the wire is on, it will use the blue command. So that's just how it works. If you don't get that, that's perfectly fine. It kind of depends on sort of depends on things such as how to build go-to systems and things. So you don't really need to get that. But all you need to know is if a condition is met, use the blue. If a condition is not met, use the grey. So that is, if it's true, do this. If it's false, do this. And that's basically how a computer makes decisions. It will go to different lines of code based on different things. So we can make this a bit more complicated by saying if the user has inputted, do something with the information. And if it's true, then this will happen, and it will maybe go to this line of code. And we'll write an instruction, perhaps this is an instruction here, and this instruction tells the computer to do what it's going to do. However, if the condition's not met, then we're not going to go to that line of code. Instead, we're going to go to whatever line of code this says, which might be, I don't know, this line of code here. And we might put some torches here. And I don't know, that could mean like, don't do anything. So if the user has inputted, we're going to do something. If it hasn't inputted, then it'll go to this line of code and we won't bother. So basically it's all in the program, it's all in whatever program you're doing. So let me just take out these torches. There we are. So you have an if and else statement, which is the very like the bread and butter of boolean logic. This is boolean what you're learning, if and else kind of thing. So you can go to a specific line of code and there can be an instruction on the line of code and you can continue just as you were, doing a completely new program. And else, you can go to some different line of code. So if and else, that's only two separate lines of code doing separate things. And because the program is on the line of code, the instruction that you will do, based on the condition, is purely made from the goto system. And the instructions are wherever you're going to. So again, that's more about the structure of computer. Wow, I'm really high up. This is scary. Wow. Anyways, this is more about the structure of computing. Again, if you don't get all of that, don't worry. All that you need to know is if condition is true, go to some line of code. If it's not, go to another. So if it's true, and else, do this. Yeah, that's the idea. I hope you sort of got that. And I hope you found it interesting, and we'll discuss what we'll be doing next time in the next slide. Until then, I'm going to turn off Minecraft, so very exciting. Alright, so now in our computer, it can make decisions, and it can decide what line of code it's going to, what instruction it will perform, the instruction that's held on this line of code, or the instruction that's held on that line of code, based on a condition. If you understand this, then the next part of conditional branching should be a piece of cake. This was the hard bit, the deciding what program to go to, what instructions to compute. This was the hard bit. This is the bit that's going to get you to give up on computing and go and do something else. For example, rocket science or something, which is interesting as well, equally as important. But I wouldn't give up just yet. Perhaps watch this video one more time to try and understand it. If not, there are plenty of other videos for you to watch. Get a few videos in, because this is a really difficult topic. You really need to understand Boolean, conditional branching, if then else statements. Really important, especially for this next bit, which we'll be using conditional branching for. And in next time, we will be doing conditional branching again, except this time we're going to incorporate a little bit of math. So if the answer to this is greater than what I want it to be, then we'll do this. If it's less than or equal to what I want it to be, we'll do this. Or it could be like, if the math comes out negative, then reverse the signs and do something else, and if it comes out positive, leave it as it is. So we're going to be doing some math, and we're going to be doing some conditional branching based on mathematical calculations. So if you like this lesson, then make sure you continue with this series. I've really enjoyed making it, just talking about what I know. I hope you have, and if you have, then I'll see you next time.